Hi, this is Susie, and this is my end of quarter video for knowledge maps. Let me present this. So let's start off by talking about what the point of knowledge maps even is. To do that, I need to first define who my set of users are. My user demographic are basically advanced novice web developers who have used CSS before. They're familiar with the syntax, with general concepts and techniques you can use, but they're definitely not web development professionals yet, and they want to be. So the main goal is for these novices to become CSS professionals. But what does that actually mean? Well, to start off, professional will understand the CSS code and techniques used in individual professional web examples. And this particular aspect of professional knowledge is heavily addressed by tools like Ply, Telescope, and whatnot. But there are other parts or other types of knowledge that a professional should have, such as recognizing how the same CSS implementation technique, such as CSS Grid, CSS Flexbox, can be used to implement a variety of web features, and also recognize the nuanced differences in how you can apply that same technique in different ways. So there are several existing approaches or many tools trying to help novices become professional web developers, but they do not address the problem that I'm trying to address. For example, tools such as Ply, Telescope, and Unravel are effective at scaffolding novices to sense make and replicate professional code for individual examples. And this is also important, but it is only the first step to becoming a professional web developer, because not only do you have to have an understanding of each example on its own, you should also be able to see how their underlying concepts that several different examples that may look very visually different are still employing in the same way. Some other approaches that come closer to addressing the issues are interactive example galleries. These are tools that allow novices to learn by interacting with multiple professional web examples at once. However, interactive galleries that exist right now are meant to provide web design inspiration, and although they're effective at that, none of them are specialized to provide scaffolds for recognizing common web development and implementation techniques, or in my case, CSS implementation techniques, across professional examples. And here is a photo or screenshot of the Adaptive Ideas web design tool, which is an interactive example gallery developed by Stanford, but as I just mentioned, it only works for web design, not web implementation. This leads into the research question that I am attempting to answer, which has not been answered yet, which is, how can we provide novice web developers scaffolds such that they can build a strong conceptual understanding of the application of professional CSS implementation techniques in different contexts? My main conceptual approach will be to provide a tool called the Knowledge Maps tool that scaffolds novices to compare and contrast professional examples and generate their own concept maps based on their findings and what they notice. Here's a slide summarizing the contributions I made over this quarter. To start off, I submitted a URG, which helped a lot because I didn't touch the research canvas before jumping into my URG, so this helped me define a clear research question, which is this guy, and also helped me articulate the gap in academic literature that I'm addressing, which is this guy. I also did 4 complete iterations of prototyping and testing, so I really did some agile methodology. All of these prototypes were paper. I designed and conducted studies for each of them to synthesize the user takeaways and then iteratively revise my interface and system arguments based on the results. So now I'll jump into the design arguments and my interface/system model. I'm going to kind of explain them together because I think that's how they make the most sense. My first design argument for the Knowledge Map tool is to provide code highlighting to remove the busy work of finding lines of code between examples that could potentially be responsible for a common CSS implementation approach. This leaves the rigorous and meaningful task of discovering and articulating the underlying conceptual similarity to the novice while making finding the code that could be responsible very quick. So the main obstacle this is overcoming is avoiding the novice from wasting time on the useless work of finding code that could potentially, and it's not even a guarantee, to reflect a conceptual similarity between examples. My second design argument is to use guided reflection and articulation to help learners distinguish between surface and conceptual differences and gain a thorough understanding of the rationale for their groupings. The obstacle this design argument is addressing is to prevent novices from walking away with a shallow, very superficial or hazy understanding of this underlying CSS concepts reflected by these examples, which is what I saw a lot in the prototype that I tested in fall quarter. So to get like a better picture, because I went through so many different iterations and prototypes, here's a general timeline of each prototype, what kind of characteristics and design arguments they actually reflected, and what I added with each iteration. So my first prototype, which I tested during status update, mainly implemented just the design argument about code highlighting. I tested 2 tiers of highlighting, which I'll describe later on in more detail, to draw attention to the common lines of CSS across examples. In the second prototype, I kept the code highlighting, but now I added articulation prompts that the users had to answer each time they selected an example. And at this point, they were kind of generic. Like, it would just be stuff like, how are these 2 examples similar? And something like that. But the reason I decided to add that was because in my first prototype, both Kapil and Judy were very confused about what they had to do. They recognized that that when they selected something, lines of code were highlighted, but they didn't know how to effectively use that characteristic, so they needed more scaffolds to help them along the way, which is why I added that second design argument. So now at this point, at the end of the second prototype, I had 2. Starting with the third prototype, I started revising the characteristics more. I kept my design arguments, but started ironing out more details. I made the articulation prompts, which is a throwback to design argument 2, very code line specific. And again, I'll show a table of this in some later slides. I also started scaffolding myself out of the prototype, both in prototype number 1 and prototype number 2. The study would start off with me basically just delivering a mini lecture explaining each example. But I realized, first of all, that's not automatable. And second of all, I might be, unfortunately, scaffolding them to recognize certain concepts between the examples, and maybe they wouldn't have been able to figure it out organically on their own, which is what they're supposed to do with this tool. So understanding those risks, I decided to start taking myself out of the picture. And in the fourth prototype, I realized that I tried to scaffold myself out in prototype number 3 by providing them links to online documentation, but the users and novices were extremely overwhelmed by all the information provided to them, because 99% of the information on, for example, the attributes grid template columns is irrelevant to the particular examples that they're examining. So in prototype number 4, I provided sliced interactive code pens that they could use that show the particular application of grid template columns that is relevant to the example they're examining, instead of just generic online documentation. And this was a lot more helpful and had them figure out what was going on a lot more efficiently. So now I'm showing my paper prototype. This is what happens when a user selects example D, which is what is on the left. In later versions, I decided to also highlight the lines of code in example D, but this is the version I did at status update when I wanted to make sure that Gopi and Maxine weren't overwhelmed with all of the instructions. So as you can tell, all of the other examples are hidden, as in you don't see them, so you only see the 2 other examples, which are example E and G, that have lines in common with example D. The rest of the examples don't have any lines in common. And amongst the highlighted lines, which are marked with orange sticky notes, there are 2 tiers of highlighting. The first tier is when the CSS attribute and the value are the same, such as display flex, which is tier 1 highlighting shared by all 3 of these examples. And there's also tier 2 highlighting, in which only the CSS attribute is shared. And this is something such as flex, such as background color or padding. So this photo demonstrates the characteristic associated with the first design argument about code highlighting. This table is the system model essentially for the second design argument about reflection and articulation prompts. This is the table I made for prototype number 3. So this table is a lot longer since there are around like 8 examples, but here are the 2 main examples that I thought were most interesting. The first one is when you select example C, which is an example of a grid. And there's example F, another example that uses a grid, but the main difference here is how they use grid template columns. So the articulation prompt specifically asks about that by asking, the example you selected, example C, has 3 instances of the grid template columns attribute, while example F only has 1 instance of the grid template columns attribute. Explain this difference and why you would use one over the other. First of all, it's automatable to count the number of grid template columns, the occurrences of them, and it drew attention to how example C used explicit media queries while example F did not. And finally, although this is not connected to a design argument, this is how, instead of providing generic online documentation, I provided them code pens that sliced out exactly the concepts that they needed to know. If a user was confused about flex direction, I would direct them to this code pen, which I did not create from scratch. This is actually sourced directly from the MDN online documents, meaning this is fully automatable. Now to jump into the studies. The general study methodology. So I completed 4 separate iterations of studies, but the general format for each study was more or less the same, excluding my status update, which was kind of an outlier because I divided up my work among several people. The facilitator was Maxine and Gobi was the wizard. The general idea is that I explained the study to them. It's like, oh, here you're going to get a set of professional examples. You will have to group them and answer any questions that I ask. I also emphasize that they articulate their thought process so that I could take notes throughout the study. And once they finished making their groupings, I checked if the rationale they gave for each of the groupings addressed all the points that I was looking for. I had an answer key, which is here, and this was my main metric of success. So I wanted to see if they reached all of these points when explaining why they made a certain grouping, or I also had this answer key in particular is about the answers to the question prompts, the reflection articulation prompts. And here's a timeline of all the studies I conducted and what I tested for in each of them. In the first iteration, I tested whether code highlighting facilitated the recognition of common CSS implementation techniques across examples. In the second iteration, I tested whether having question prompts after every single selection provided better structure so that the user knew how to actually use the knowledge maps tool and not get lost about what to do next. In the third iteration, I tested whether I could successfully, first of all, scaffold myself out of the prototype, so stop delivering mini lectures, and also whether having the question prompts be much more code line specific would scaffold novices to give less wishy-washy, vague answers or rationale for their groupings. The fourth iteration, I tested whether having tailored code pens as references for any of their inquiries would help the novices understand the individual examples more effectively than if they were given generic online documentation. So now I'll quickly go over the core findings I got. I did kind of imply them, but I'll explicitly state them here. So first of all, code highlighting successfully scaffolds novices into immediately focusing on relevant lines of code when comparing and contrasting multiple examples. It took participants significantly less time to verbalize their rationale and form the groupings compared to the prototype I had during fall quarter, where I noticed that one user even spent like a whole 7 minutes just trying to find examples that had lines in common. So I completely removed the busy work of that. Also, another core finding is that question prompts specific to the code highlighted in the selected example scaffolds users into digging into the nuances of the CSS implementation, and this consequently helps them spot subgroupings that they might not have noticed before. From a study on my third prototype, one of the participants stated that answering the question prompts basically surfaced the subgroupings that I can form within the selection that I see. And this happened when he was forming groupings for examples G, D, and E, which were the Flexbox examples that I showed earlier on in this example. Because before prototype number 3, most people grouped these 3 together and just said, oh, they all use Flexbox. But this time, the novice was able to form example D and G and into their own subgrouping and E and as a separate subgrouping while having them all under the parent grouping of Flexbox. And this became, and not only that participant, but all of the participants were able to make those subgroupings thanks to the question prompts. Finally, providing documentation that's tailored to specific highlighted examples or the question prompt at hand reduces the time it takes for the user to understand the individual example thoroughly or enough to make a meaningful knowledge map. So, discussion and next steps. I learned that the combination of highlighting and reflection/articulation prompts is incredibly effective at scaffolding novices to spot CSS implementations across examples and also understand the nuances of how those implementation examples are used on particular examples. Of course, there's still a lot of work to do on to iron out some specific details of the characteristics to manifest these design arguments, but it's definitely the right approach is what I got. And there are several things that I can do next. One is to push towards making the question prompts become more like interactive exercises, which also plays into integrating Ply into my knowledge maps tool, but I should definitely have a stronger argument for it or more outcome-driven argument for it before I actually do this. I also want to test the prototype on a new set of examples to see if the characteristics generalize to a different set of examples. They work great for my current set of examples and are theoretically automatable, but that doesn't mean they'll be equally as effective in a random set of professional examples. Another next step is to implement a digital prototype. I already started it in the GitHub repository, which has some basic code highlighting, both tier 1 and tier 2. You can toggle between the two. But actually implementing the full thing and starting to do prototype testing on the digital version could be a potential next step. And now the final general takeaways and the implications. Although I do feel like I'm repeating myself, the 3 main takeaways was 1, the code highlighting makes the process of comparing and contrasting examples significantly more efficient. The second takeaway is that reflection and articulation prompts scaffold novices into gaining a deeper, more nuanced understanding of the examples. And the third one, which was a relief, is that I can be scaffolded out of the prototype as long as I provide rigorous tailored resources to the users. And this is great because the implication I get from all of this is that the characteristics that I worked on during this quarter can definitely be automated, which is very important. As I mentioned before, there's still definitely the risk of whether these characteristics would be equally effective on a different set of examples, but at least they can be automated.